Hi guys, this is going to be a quick video about specific heat capacity. So, specific heat capacity, you can think of it as the kind of inertia that an object feels when it changes in temperature, right? So, when you take a look at specific heat capacity, there is one equation that you'll be using, which kind of describes it, right? And so, if you think about it, well, you're going to need some amount of heat, right? And so that heat is going to affect a change in temperature. Okay. And the two variables that affect how much an object changes its temperature is what it is. That is, we have a specific heat constant for that object, and we have its mass, right? So, specific heat capacity, this is the formula, right? Heat Q is equal to mass times the specific heat constant times the change in temperature, right? So you can kind of think as CP as this kind of inertia that an object feels, right? The inertia of temperature change. Okay, the inertia of temperature change. Okay, that is if CP, if the specific heat capacity is really high, that means it's going to be really hard to change the temperature. If it's really low, it's going to be very easy to change the temperature. Okay, so what are some different problems that we can do with this equation, right? So, what are some different problems? Well, imagine you had, let's say, a block of, or not a block, but a beaker of water, right? And let's say you had 100.0 grams of water, and you wanted to heat this water up. Okay, let's say this water was going from 10 degrees Celsius to 50 degrees Celsius. Okay, well, the question to ask yourself is how much heat is required to bring this 100 grams of water from 10 degrees Celsius to 50 degrees Celsius, right? You're going to need a constant here, and the constant for water is 4.184 joules per gram degree C, right? Energy per mass unit per degree of temperature. So we can write our equation, Q equals mCp delta T, right? And so we have temperature values. So we have temperature, we have Cp, we have that, we have mass. So all we have to do is to find heat. Okay? So to find the change in temperature, we're going from 10 degrees Celsius to 50 degrees Celsius. So change in temperature is going to be the final state, 50 degrees Celsius, minus the initial state, 50 minus 10, or 40 degrees Celsius. So let's plug in these values. Q is going to be equal to 100.0 grams times 4.184 joules per gram degree Celsius times 40 degrees Celsius. Okay? So if you do the math, right, grams cancel, degrees Celsius cancel, and you're left with the unit joules, the unit of energy. So we know that this is good. Okay, so 100 times 4.184 is 418.4. Multiply that by 4, and you get 3672, 73.8. So, 73.8 plus 1600, so 1673 joules, about, right? Just doing some quick mental calculations. Okay, so it takes 1,673 joules of heat to bring this water, 100 grams of water, from 10 degrees Celsius to 50 degrees Celsius. Okay? There are other problems, right? Let's say you know how much heat you added, right? Let's say you know how much heat you added, but you don't know what the temperature is going to be. Let's say we have that same beaker of water, 100.0 grams, and let's say we added 800 joules of heat. Okay, so we add 800 joules of heat to the water. First of all, since you're adding energy to the water, the temperature should go up. Okay, temperature should go up. So we'll just keep that in mind when we calculate this. So we again have Q is equal to mCp delta T, right? I should mention that the initial temperature is 10 degrees Celsius. All right, so what is the final temperature of this water? Well, we're going to try and find a change in temperature. So we're going to rearrange this equation, right? The way we rearrange it is divide both sides by mCp, and we get change in temperature is equal to Q divided by mCp. Okay, so we can plug in the numbers. Delta T is going to be equal to 800 joules divided by 100.0 grams times 4.184 joules per gram degree Celsius. Okay, grams cancel because numerator denominator, right? Joules cancel because numerator denominator. If you're in the denominator of the denominator, that brings you back to the numerator, right? So the units do work out. So if you were to calculate this, and let me calculate this real quick, can't do division in my head like the other one. Well, we have 800 divided by 100. Well, that's 8. 8 divided by 4.184. It's going to be 1.91 degrees Celsius. Okay? 1.91 degrees Celsius. I did the math wrong in this other problem. I think that should be 16.73. Let's check my math. No, yeah, I should check my math more often. Anyway, right? Okay. So 800 joules into this will change the temperature by 1.91 degrees Celsius. Okay. All right. So that should be it. Okay. Make sure you check your calculations. Don't be me. Don't try to do things in your head. Put it into a calculator. All right. Oh, and didn't calculate the final temperature. That's only the change in temperature. So the final temperature, because we're adding energy, it's going to be the initial plus 1.91 degrees Celsius, or 10 degrees Celsius plus 1.91, or 11.91 degrees Celsius. Okay? All right, so make sure you do your calculations and be careful. Take care.